Hello learners, today we will discuss about the chapter Polymers. Have you ever wondered that from a toothbrush to synthetic clothes, to automobiles to electronic gadgets like mobile phones, computers, to lifesaver silicon heart valve, polymers are used in almost every material we encounter on day-to-day basis. Polymers are abound in nature. The cell wall of plants is made of cellulose, a natural polymer. A strand of DNA is a natural biopolymer. In 1869, while treating cellulose derived from cotton fiber with camphor, John Wesley obtained a plastic that could be crafted into various shapes and made to imitate natural substances like linen, ivory. This led to the invention of first semi-synthetic polymer, while in 1907, Leo Baekeland obtained the first synthetic polymer, phenol formaldehyde resin called bakelite. This invention marked the introduction of polymer age. Over the period of time, the use of polymers has completely revolutionized the daily life and industrial scenario. Indeed, polymers are the backbone of four major industries: plastics, elastomers, fibers, and paints and varnishes. During this discussion, we will explore about polymers and macromolecules. We will define some frequently used terms such as monomer, polymerization, degree of polymerization, and what is the difference between homopolymer and a copolymer. We will also talk about properties of polymers that make them unique and how polymers are classified into different groups and subgroups. We will begin with what is a polymer. The word polymer is coined from two Greek words. Poly means many and mer means unit or a part. The term polymer is defined as very large molecules having high molecular mass. These are also referred to as macromolecules. Thus, polymers are macromolecules formed by joining of repeating structural units on a large scale. The repeating structural units are derived from simple and reactive molecules known as monomers, which are linked to each other by covalent bonds. The process of formation of polymers from respective monomers is called polymerization. The number of repeating units in the chain is called degree of polymerization. Polymers having monomers of one type are called homopolymers. The transformation of ethene to polythene is an example of homopolymerization. Polymers having monomers of two or more types are called copolymers. The interaction of hexamethylene diamine and adipic acid leading to the formation of nylon 6,6 is an example of copolymerization. I hope you all would be very amazed to know that the process of copolymerization has been used by nature as well. Proteins that are essential part of all living organisms are formed from one or two polypeptides joined together. These polypeptides are very important polymers which may contain as many as 20 different amino acids. Dear learners, while referring polymers as macromolecules, it must be remembered that all polymers are macromolecules, but all macromolecules are not polymers. For example, sucrose is a macromolecule and its formula is, you all know, it is C12H22O11. It is not a polymer. At the same time, lipids are also macromolecules and are not polymers, as they are made up of smaller units of different kinds such as glycerol and fatty acids rather than monomers that repeat themselves. So, these are two very important examples where even if they are macromolecules, these molecules are not polymers. The question that arises is, what makes these polymers unique? It is the length of the chain and the pattern in which these chains are linked makes the polymer strong, lightweight and flexible. Many polymers possess high tensile strength and high modulus. Do you know what does the term modulus signify? Modulus of a material describes how well it resists deformation. It is expressed in terms of force per unit area required to produce deformation. I hope you all have understood this. Polymers are also insulators, that is, they resist flow of heat and electricity. These properties make synthetic polymers exceptionally useful. And there are several ways of classifying these polymers based on some certain special considerations, and we will be talking about each of them in this episode. We will discuss about 5 different ways of classification, starting with classification based on source. Under this type of classification, there are 3 subcategories: natural polymers, semi-synthetic polymers and synthetic polymers. Now, what are natural polymers? These are obtained from renewable resources and are found in plants and animals. A few examples are starch, cellulose, rubber and some resins. While semi-synthetic polymers are derivatives of natural polymer, cellulose. A few examples are cellulose acetate, which is commonly known as rayon, and cellulose nitrate, which is also called as nitrocellulose. The third type of classification is on the basis of mode of polymerization. Polymers can be classified into 2 subgroups: addition polymers and condensation polymers. We will first talk about addition polymers. These polymers are obtained by repeated addition of monomer molecules possessing double or triple bond. There are certain characteristics that you need to remember, that these monomers either do not contain functional group or contain them as substituents only, and this would be understood with the help of an example as well. The polymers can be homopolymers or copolymers. If you look at the examples, the formation of polythene from ethene is an example of a homopolymer, while the formation of polyacrylonitrile from acrylonitrile shows that functional group is acting as a substituent only. In the third example, the addition of 2 different monomers, 1,3-butadiene and styrene, results in the formation of a copolymer known as butadiene styrene copolymer, which is also commonly known as BUNA-S. While in case of condensation polymers, the polymers are formed by repeated condensation reaction between 2 different bi or trifunctional monomeric units. In these polymerization reactions, the elimination of small molecules such as water, alcohol, hydrogen chloride takes place. The very common example of this category are nylon 6,6, nylon 6 and terylene. You all must be wondering that why there are 2 different forms of nylon, nylon 6,6 and nylon 6. We will be exploring about this in our subsequent discussions. As shown in the equation, the formation of nylon 6,6 involves condensation of hexamethylene diamine with adipic acid. We will be discussing at length about preparation, properties and uses of different polymers in subsequent episodes. Fourth type of classification is based on molecular forces present in the polymer. A large number of polymer applications in different fields depend on their unique mechanical properties that we have already discussed. And these properties are governed by intermolecular forces such as van der Waals force and hydrogen bonds present in the monomer. And these forces also bind the polymer chains. Based on the magnitude of these forces, polymers can be classified into 4 subgroups as elastomers, fibers, thermoplastic and thermosetting polymers. While elastomers are rubber-like solids with elastic properties, in these polymers, the polymer chains are held together by weakest intermolecular forces, and these weak binding forces permit the polymer to be stretched. And to help the polymer to retract to the original position after force is released, a few crosslinks are introduced in between the chains. The example of this type are Buna S, Buna N and neoprene. Again, you all must be wondering that what is the difference between Buna S and Buna N. And my answer to these questions is that we will be discussing about all these in the subsequent episodes. The next subcategory is fibers. These are thread forming solids which possess high tensile strength and high modulus. These characteristics can be attributed to strong intermolecular force like hydrogen bonding. These forces also lead to close packing of chains and thus impart crystalline nature. The example of this category are polyamides such as nylon 66 and polyesters such as terylene. You all must have learned so far that some polymers, they fall into, the same polymer falls into different categories. So, maybe this you can take as an assignment, a part of the assignment, that you would be writing down all different properties of a particular polymer. The next category is thermoplastic polymers. Thermoplastic polymers, these are the linear or slightly branched long chain molecules capable of repeatedly softening on heating and hardening on cooling. These polymers possess intermolecular forces intermediate between elastomers and fibers. Some common examples are polythene, polystyrene and polyvinyl chloride. The fourth subcategory in this category is thermosetting polymers. These polymers are cross-linked or heavily branched molecules which on heating undergo extensive cross-linking in molds and become infusible and thus cannot be reused. Some common examples are bakelite and urea formaldehyde resins. The fifth type of classification is based on growth polymerization. The addition and condensation polymers are also referred as growth polymers and step growth polymers depending on the type of polymerization mechanism they undergo during their formation. We will be discussing in detail about these polymers and the mechanism of polymerizations in the next episode. Let's summarize what we have learnt today. The polymers are defined as high molecular mass macromolecules which consist of repeating structural units derived from the corresponding monomers, and these monomers may be natural or synthetic. The polymers can be homopolymers or copolymers. These polymers possess unique properties and are classified in different ways based on their nature, source, mode of polymerization and nature of molecular forces existing in polymers. These polymers have immense applications in our daily life. Before we end today's discussion, let me leave you with an assignment where you have to answer a few questions. Question number 1 is, justify the following statements with suitable examples. The first statement is, all plastics are polymers, but all polymers are not plastics. The second statement is, all polymers are macromolecules, but all macromolecules are not polymers. Second question is, a polymer X repeatedly softens on heating and hardens on cooling, while a polymer Y on heating gets converted into an infusible mass. Comment on the types of polymer X and Y. Third question is, what type of polymers are crystalline in nature? Support your answer with an example. The fourth question is, differentiate between homopolymers and copolymers and give suitable examples for each. Dear learners, I hope you have understood the concepts taken up during this session. Thank you. Take care.